Hello, my name is Jocelin Maurel. I joined Fittingbox in 2022, starting as an intern in the Studio Lab team, where I evolved to become lead 3D creative pipeline developer. I carry out research to identify new functionalities capable of accelerating and enhancing our modeling pipeline. The goal is to make our in-house softwares consistent with production and modeling expectations to ensure continuity with the rest of the toolchain. Today, I would like to talk about one of the key areas we are exploring to improve our pipeline, parametric modeling. Instead of creating a static object, parametric modeling builds it using rules, formulas, and relationships. For example, rather than manually drawing a 2-meter-long cube, we define a value called length. If you change this value, the cube updates automatically and there is no need to redo the whole model. Mostly, yes. And at Fittingbox, we use two main types of modeling processes: polygonal modeling and NURBS modeling. Each type of modeling processes allow us to achieve different levels of quality, but also to respect certain customer specifications. In the previous expert talks, Maxime introduced you to plugin development in Blender, which is principally based on polygonal modeling. Today, we are going to talk about NURBS modeling, which we use in Rhino, a CID design software. In NURBS modeling, the user creates curves that form surfaces when connected. By joining several surfaces, you can generate solid volume objects. This approach is central to modeling in Rhino. To support that, we create custom software layers that give us control over the complex parameters of the surfaces, all through a dedicated interface. As you can see, we have built a custom overlay on top of Rhino. This interface allows us to manage the complex inputs that define the shapes of eyewear frames. It helps us to get the desired shape faster without needing to navigate all of Rhino tools manually. Thanks to this approach, we can even reopen the file later to make quick adjustments by simply updating values. Once the object is modeled, we can move on the next key step, meshing. Here, we convert our surfaces into a polygon mesh, compatible with the rest of our tools. The mesh density, meaning the number of polygons, varies depending on the level of visual quality required. After meshing, we generate UV maps for each object part. At Fittingbox, we have automated this process using our internal toolchain. Thanks to the metadata captured during modeling and our in-house algorithm, we can automatically deploy UVs, preparing the data for texturing. These maps associated to the model are then used by our graphic artists who add textures and final visual details.